Hey everyone, in this video I want to talk about the powers of imaginary numbers and how far we can go with their exponents. So let's just talk about I real quick. So as we know, I is the square root of -1. Okay, so what is I to the 0 power? And as we know, anything to the 0 power, with the exception of 0 to the 0 power, of course, but almost any other number to the 0 power is 1, and I is no different. I to the 0 power is simply 1. Good, and what is I to the first power? So, again, any number to the first power is just that same number, and I is no different. I to the first power is simply I. Good. Now, what is I squared? I to the second power. Okay, so we know that I equals radical -1. So what is I squared? Well, I squared is simply I times I, which is radical -1 times radical -1. So in other words, it's radical -1 squared. And what's the square root of a square? It's simply just the radicand, so this is -1. All this to say is I squared is simply -1. Good. Now what about I to the third? Let's go even higher. I to the third power. Well, I to the third power may not seem intuitive, but we know using the product rule of exponents that I to the third power is the same as I to the, what's 3? 3 is simply 2 plus 1. And we can break up this exponent, or this term, into two numbers with exponents. So I to the 2 plus 1 power is I to the 2 times I to the 1. And this is because of the exponent, or the, the product rule for exponents. The product rule for exponents. And we know what I squared is. I squared, like we said, was just -1. So I squared is -1 times, and what is I to the 1? As we said before, I to the first power is just I. So I to the first is just I, so -1 times I. What's -1 times I? That is -I. Therefore, I to the third power is -I. Good. And let's keep going. What about I to the fourth power? How do we get there? Well, we can kind of do the same thing. I to the fourth. What two numbers add to 4? You can go the 2 plus 2 approach or the 3 plus 1 approach. You will ultimately get to the same answer, but I would just like to show you what happens if we go to the 2 plus 2 approach. So I to the 2 plus 2. Good, so that means it's I to the 2 times I to the 2, according to the product rule. And what's I squared? Like we said, I squared is -1, so -1 times -1. So what's 1 times 1? That's 1. And what's a negative times a negative? That's a positive. So -1 times -1 is simply +1. So I to the fourth power is just +1. And good, let's go just a few more. So let's go to I to the fifth. I to the fifth, how do we get there? So I to the fifth, that is simply I to the 4 plus 1 power. And we can break that up, I to the fourth times I to the 1. What did we say I to the fourth was? I to the fourth, as we just evaluated, is 1. So I to the fourth is 1. So 1 times I to the first, we said I to the first, we said I to the first was I. Any number to the first is just the same number. So I to the first is I. And what's 1 times I? Well, what's 1 times anything? It's simply just the same number. So 1 times I is I. So I to the fifth is I. And let's go one more step. I to the sixth. So let's just go through this quickly, and let me actually erase some of this. Just wanna make some space. So I to the 6th power, we're going to do the same thing. I to the 6th is I to the 5th plus 1, which is I to the 5th times I to the 1st. And what did we say I to the 5th was? I to the 5th, we said was I. So we will go ahead and substitute that. I to the 5th is I. And what's I to the 1? I to the 1 is also I. And what's I times I? I times I is I squared. And what did we say I squared was? We said I squared was -1. So I squared is -1. Therefore, I to the 6th is -1. Okay, so I think we've done enough, and you might notice a pattern right here. We start at I to the 0, which is 1. I to the 1 is I. Then we have I squared, which is -1. You have -I, 1, I, -1. So there's actually a pattern here. There's a cycle. So it starts at 1, 1, I, -1, -I. And then it repeats. 1, I, -1. And even if you go to I to the 7th power, I to the 7th, this happens to be -I. And this repeats forever. 1, I, -1, I. 1, I, -1, I. It repeats forever. So you can predict the next few powers. So I to the 8th, I to the 9th, I to the 10th, and I to the 11th. It's the same pattern. It's 1, I, -1, I. So I to the 8th is 1, I to the 9th is I to the 10th is -1, and I to the 11th is -I. It's the same pattern. 1, I, -1, I. So the cycle repeats every 4 powers. So every 4 powers, and that's the key. Every 4 powers. And the key here is to look at every power of 4 and their factors. So take a look at I to the 4th power. I to the 4th power is 1. Okay, so what's I to the 8th power? I to the 8th, which is really 4 times 2. 8 is just 4 times 2. I to the 8th is also 1. And you might be able to guess just from continuing this pattern, I to the 12th is also 1. So is I to the 16th, that is 1. I to the 20th, that is also 1. Every number that has a factor of 4, or every number that has a factor of 4, I to that power will give you 1. So I to the 32nd power will give you 1. Every number that has a factor of 4. So this helps us because we can predict higher powers of I. So let's say we had a large number. Let's say we had I to the 410th power. So we could go ahead and do this manually and go through this pattern every 4 powers until we get to 410, but that would take a while. So what's a shortcut? Well, we can take advantage of the fact that every number that has a factor of 4 is I to that power will give you 1. So 410 actually doesn't have a factor of 4. But what does? 400. What's the closest number that does 400? So 400 is 100 times 4. Good. And what about 404? Well, 404 is 101 times 4. So 404 is also a factor of 4. So we know that I to the 400 equals 1. I to the 404 equals 1. And even 408 if we add another 4 to this. So if we just keep adding 4, so 408 is 102 times 4. So I to the 408 also equals 1. And we can go another 4 to get to 412. Apologies, so 412, which is 103 times 4. They all have factors of 4. What is I to the 412th? Well, I to the 412th equals 1. So we are looking for I to the 410th power right here. And that is between 408 and 412. And I to the 408 is 1, and I to the 412th is 1. Okay, well, we might not know what I to the 410th power is, but we know that 410, how do we get from 408 to 410? So 408 plus 2 is 410. 410 is simply 408 plus 2. Therefore, we can rewrite this. Let me actually bring it down. Let's erase some of this. I to the 410th power. So 410 is simply 408 plus 2. And again, we can use the product rule to break this out. So I to the 408 times I to the 2. What's I to the 408? Well, we just determined up here, I to the 408 equals 1 because 408 is a power of 4. Or apologies, it has a factor of 4. 408 equals 4 times some whole number. So 408 is a factor of 4. Therefore, I to the 408 is 1. So we know that 408 is 1 times I squared. And what is I squared? As we said previously, I squared is negative 1. So this turns out to be 1 times negative 1, which 1 times negative 1 is negative 1. Therefore, I to the 410th power is negative 1. And that is how we find higher powers of I, and higher powers of imaginary numbers. So I hope this video helps you understand the higher powers of I and how we can get there by using this cyclical nature of the powers and the exponents. And if you have any questions at all, please leave them down in the comments below, and thank you for watching.